Here I am back within the XML view of the awltmodel.edmx file. I'm going to expand this conceptual models section here, drill down a little bit so that you can see how it's structured. So this is the overall structure of this part of the runtime section. So the containing element is this schema. And schema contains an entity type for each of the entity types within this model, and associations, as well as an entity container. So this defines the namespace for the AWLT model, as well as various namespaces for the different parts of the XML. And what these namespaces do over here is to link the structure of this XML to the XML schema files that are defined for this CSDL section. All right, but then otherwise schema is just a container for all of the objects within the conceptual model. And again, keep in mind, this is the model that determines the shape of the entity data objects that Entity Framework creates the code for, and that you then use within your application. All right, the entity container object down here, I'll go ahead and expand that, is named AWLT entities. That's the name I gave it in the wizard that I used database first in order to reverse engineer this database. This is a wrapper for the entity set and association set elements, as well as it functions as the entry point for querying the model. As you'll learn when you see how to query entity data objects, you'll create link expressions that use the entity container, this AWLT entities object in this case, and an entity set to retrieve collections of entities or single entities. This annotation for lazy loading enabled guides how Entity Framework creates objects to use or not use lazy loading data into data objects. Lazy loading is just a way to essentially save performance. Entity Framework, by default, only loads data into an entity object when it's needed. It doesn't fully populate an entity object. You can change that default, though. All right, then you have the set of entity set objects here. And these are just a container for a single type of entity, with a name attribute and an entity type attribute. And this links the entity set to the entity contained within the set using the entity's strongly typed name. For example, the customer's entity set right here contains awltmodel.customerEntities, and that's identified here as self.customer. So the entity set provides access to individual entities when you query the model. All right, then there are these association set objects here. So if I expand the one for customer address here, you can see that this is a container for an association. All right, so this is an association set, and it might seem a little bit strange to have an element that describes a set of associations. But Entity Framework uses this element to keep track, in this case, of a customer entity that has multiple associated customer address entities in memory. In this case, there would be one FK customer address, customer, that whole long string name. There would be one entity instance for each address that's within memory. And then these end elements bind each end of the association to the applicable entity set, which lets the Entity Framework move through the model to discover entities that are related to each other. So now you can see how, by looking at the XML, you can see how Entity Framework implements various features that you can actually design and put together using the Entity Data Model Designer. Okay, so that's the entity container. Now I'm going to come up here to these entity type objects. Again, this is within that schema element that's part of the conceptual model. There's one of these entity type elements for each entity in the model. And so if I stick to the theme of looking at the customer object, I can expand that there. And you can see that there's a key element that defines the entity key property. And again, this uniquely identifies each entity in the entity set. And here it's using a surrogate key. Once again, it's similar to a primary key within a relational table. An entity can have multiple entity keys, though, in order to make up a composite entity key, which is similar to compound keys within relational databases. And then the entity type has a number of property elements, and there's one for each entity property. Each property includes at least a name and type to identify that first name is type string, for example, and then any facets that have to be identified or that you set within the designer. The data types that are used here are simple types, which are primitive types that fairly closely correspond to the native data types within the .NET framework. You can start to see how this XML implements and stores the properties that you can set as you work with the designer in order to modify entities, create properties, set the properties of the properties, define data types, and so forth. One big thing to note here. As you explore this XML and compare the various elements here to the list of properties in the Properties window when you have the graphical designer open, you'll find that many properties seem to be missing from the XML file. This is because, for the most part, Entity Framework includes XML attributes for many objects only if the attribute, again called a property within the designer, is changed from its default value. This is far from a universal rule, though, but it happens often enough to sometimes be confusing as you search for a setting. So if you compare, for example, the attributes of the first name property of the customer object when the designer is open and the XML, you'll see there's no XML attribute for the getter or setter. And that applies to concurrency mode and various other properties. But if you were to change the values of those properties in the designer, then attributes would appear in the XML for those properties here because you've changed them from the default values, and Entity Framework has to store that information someplace. Okay, then back to the entity type here. Each entity type has a navigation property element for each navigation property of the entity. And once again has a name, so that's the name that appears within the designer, and then a relationship attribute that defines how this is related to another entity. And then if I scroll over here to the right, you can see there's a from role and a to role that defines the relationship between the two entities for which these navigation properties apply. Okay, so that's the customer. I'll collapse that. And notice here that there are entity types for the views that I included as well. So if I look at one of these, I'll expand the View Get All category here. Really, the only notable new thing about these view definitions is that when it created the model, the Entity Data Model wizard found that there were no primary keys for the views. So the wizard inferred entity keys for the views using any non-nullable properties in the table schema. So as a result, for this Get All Category view, it ended up using the parent product category name field as the entity key, because that's the only non-nullable field within that view. But if I look at V product and description and drill down into the key, you can see that it has a composite entity key consisting of product ID name, product model, culture, and description, because those are all of the non-nullable fields within the view. Okay, so it's a little bit of a manufactured way, but it provides the option for Entity Framework to keep track of the different records that you might get back from a view. So in fact, if I go over here to Management Studio, and I go to the view definitions here. Actually, I want the AdventureWorks LT 2012 database here. Drill down into views and the product and description, and I look at the columns. You can see which are the non-nullable fields: product ID, name, product model, culture, and description. And so it used all of those in the hopes that those in combination will provide a unique key into the data that's going to be returned from the database. Okay, so one potential issue with this is that the Entity Data Model Wizard can't create an entity without an entity key. So if a table or view has no non-nullable fields, then the wizard won't create an entity for that table or view. No entity at all will appear. So if that ever happens, just be aware that that might be the issue. All right, so let's come back over here to the AWLT. All right, so that's the entity types. I'll collapse those. And then you can see that we also have these association elements. These define each association within the model. So if I expand this one right here, which is the association between the customer address and address, or actually, yeah, customer and address here. Yeah, look at that one. And I'll expand that section as well, all the way out. Here you can see the elements and attributes reflect the association properties in the designer, identifying the associated entities, endpoints, multiplicities, and referential constraint that define the relationship. But you can also see that the properties window associated with the designer formats the properties and values in an easier to digest format, keeping clear the two different endpoints of the association. Remember too that the XML normally includes only those property values that are different from the default values. So you usually won't find all available attributes in this XML either.